and navigate to it, and right away we are at the login box. But the attack also actually exfiltrated the password. So we take the second string, which was the password for that Manus sent us, we paste it in, and we're logged into Manus's dev box. So we have, with the Visual Studio Code experience, so we exposed the Visual Studio Code port. Hello, everybody. Today we're going to talk about Manus, which is an autonomous artificial intelligence agent developed by a startup in Singapore. And it's actually a quite powerful agent. And I noticed a few interesting things, especially around tool invocation, that I would like to walk you through. So first, here you can see the system prompt that I dumped. And we have this tool called deploy expose port, right? Which means the agent can deploy a port on its own machine to the internet, which is a very dangerous operation because we can exploit this during an indirect prompt injection attack. So this means we could write an app and have it expose the port of the app to the internet. But also I noticed that Visual Studio Code server is actually installed on the dev box. So we can just expose the entire Visual Studio Code remote session and then have full access to the computer. So that is the idea of the attack. Furthermore, it is protected by a password, and we need to know a URL, but we can leak that as we will see. So let me walk you through a demonstration where I have a malicious PDF document with such an indirect prompt injection attack. And to get started, let me actually show you here. We have the data exfiltration server where we going to send the URL and password for Visual Studio Code to. And we start out with just saying, summarize this PDF document, which is this malicious PDF document. So Manus spins up a VM, right? It has this isolated sandbox where it uploads the PDF document, and now it goes ahead, installs stuff. It uses the terminal, it extracts the data from the PDF document. It uses a terminal again, right? Does a lot of things because it's an agent. But you can see now there was a brief mentioning of an exposing a port. Now it uses the browsing tool. So a lot of stuff is going on. And now it browsed to my web server and it appended actually a URL. And if we now move over to actually look at what I received as the third party, right? I got this entire URL from Manus as a query parameter. So let's take this query parameter and let's put it in a new browsing window. Let's do like a private browsing window so you know for sure there's no authentication or anything I have. And navigate to it, and right away we are at the login box. But the attack also actually exfiltrated the password. So we take the second string, which was the password for that Manus sent us. We paste it in, and we're logged into Manus's dev box. So we have, with the Visual Studio Code experience, so we exposed the Visual Studio Code port. So now we can open folders and we can see the files and the file system that Manus actually has access to. And we can see here actually the uploaded document. I redacted the bottom part, because that's the prompt injection attack. So I redacted that. Furthermore, if we go on, and then, yeah, we can see here the various configurations files, right, where the password is stored on the machine, some API tokens, we have all environment variables. So there's a lot of stuff on this machine. If you would work with sensitive code, right, all the source code and so on would be on this machine now as well. And the really cool additional thing is also that you can see step by step what Manus actually did. So if you navigate into this, you can go back to the very beginning, and here you can see it looked at the PDF file here. That's where the prompt injection happened. The next step was it found the password. Then it went ahead to leak the password. It should be the next step. Yeah, you can see here, browse to the website, leak the URL and the password of the exposed tool. Then he created a summary of the document. It also created this like poem at the end. And yeah, in the end, we got all the information via that data exfiltration channel. So I hope this was interesting. I did report, of course, this information to the vendor, about 90 days ago. We had some conversations back and forth, but I am unclear if they're going to implement mitigations. I think there's a couple of really interesting steps that could be taken. Like, for instance, when exposed port is called, that by default it would assign an IP restriction that can be predefined. Another avenue, of course, is to not allow the data exfiltration to happen so easily via not rendering markdown images or not browsing to untrusted domains. So there could be an allow list of domains that is pre-configured to mitigate that, or otherwise ask the user. So I think there's a lot of improvements these coding agents can actually do, but it's still very early days. So with sharing this information, I do actually hope that we have more discussion around these problems, threats, and also the solutions that would be possible, right? We cannot mitigate prompt injection. That will probably be there for a long time. But what we can mitigate and where we can put hard security boundaries in place is when we do take actions based on LLM output, right? We need to make sure that those actions and tools are human-led and not AI-led. With that said, I hope this was interesting and useful. Have a great day. Bye-bye.